Hello everyone, my name is Paul. I work for a company called Micrographics in Cape Town, South Africa, and we are an Autodesk reseller. Today I'd like to take you through the modeling of post-tensioned tendons for Revit structures. It was a question that was asked of me recently by one of our customers. How would they go about modeling something like that? And so in this video, I'm going to describe to you how to model the anchor component and also how to model the tendon component. So for anybody who's confused what we are talking about, and surely it was something new to me as well, I just had a look around the internet and I came across this many websites, but this is one of them, just showing how there's an anchoring component and then there's the tendon. You get two types of post-stressed tendons. The one is sheathed and the other one is embedded within concrete, and so basically pre-stressed and post-stressed. So to start off with, I'm going to model the anchor component. I'm starting with the anchor because it will show how everything fits together ultimately, and to do that we'll create a new family, and the new family we can create from the metric generic face-based component. This is important to choose it as a face-based component, and we'll open that. It opens up a new family. It's got the two reference plane and the host, and we'll save that file, save as family, and I'm going to save it within my working folder. Right, so there is, I've saved it, and here is the blank family. So let's have a look at creating an outline for the structure. I'm going into a back elevation so I can see this from the side. I'm always careful to hide the elements that I don't want to use. So I'll temporarily hide that element, that's the host, and temporarily hide the level element, so that I don't constrain anything to that level or that host. Instead, I'm going to, if I reference everything, I'll reference it to that reference plane. That reference plane I'm just going to call the anchor base, so that I can refer to that when I'm modeling. I can actually choose that named reference plane, and then I'll create another one. There's a reference plane command. I'll pick a line and I'll offset that. So if we have to think about how long this thing is, I don't have exact measurements on me, but let's say it's something like 120 millimeters. Then we'll offset that by 120 millimeters, and there's then the other reference planes, and I'll just call that, what did we call the bottom one? What did we call the bottom one? We called it the anchor base, and we'll call that the anchor top. Okay. Then we're going to have two more, an anchor base offset and an anchor top offset. It'll become apparent shortly why we are doing that. So we'll create the reference plane. Again, we'll pick a line. I'm going to choose something like a 20 mil. Offset that off the base and offset that off the top. And again, we'll name them. So that'll be the anchor base offset and the anchor top offset. So the way that I'm working now is quite common if you want to use these reference planes to manipulate these elements with. Now, with any family, you'll see that we have the option to share it, the family, all right? And if we share that family into a family that we nest this family into, then we will be able to manipulate this family parameters with the other family's parameters. And in addition to that, we can also get this specific family to schedule out. Just note that when you do that, then the schedule will tally all the families, and it's difficult to say what's what. We don't, strictly speaking, in this case, need to do that, but I just wanted to mention this. A lot of people don't know that, and we'll maybe see, maybe you can use that in future if you need. All right, so let's see if we can label some of these. You can see how the label seems oversized over here. That's because of the scale that we're working to. If we change it to 1:5, we can see it much clearer. And with typical dimensions, you can also label them. And let's quickly label that with tendon. This is the anchor length. That could be an anchor length. It'll be a data type, dimensionless. Make a type parameter, yeah. Okay, and there is our family type parameter called anchor length. For good measure, what you could also do is just to differentiate. You could always edit that parameter afterwards, and I'm just going to put in there my initials PFS. That will just identify my parameters to me. It's 120. And to drive the geometry, if you wanted to change that, you could do that to 130 or back to 120, just as you wish. Right, so we're basically creating a flexible family over here. We'll create another dimension over there, and we'll say that is the anchor PFS anchor base offset. There we go. And then we've got the anchor top offset. Okay, and we'll use this when we generate the geometry shortly. And there is the anchor top offset. We can name that PFS anchor top offset. I see I made a spelling mistake. I can always go back to my parameters over there and rename that to top. Okay, so you can see there we've got our parameters, and they're able to drive the geometry that we've got over there. Next thing to do, we model some geometry. Now I'm just going to model a circular prism at the bottom, a circular prism at the top, and a taper that connects them. So the easiest way for me to do that is to start on a reference level. There I'll use a create extrusion command. To create extrusion, I'm going to use a circle. Automatically, you can see it will select the intersection over there. It's quite easy. And then we'll give it a diameter. I'm not going to parameterize everything within this family, although I can. It's just going to take too much time. And so maybe the diameter over there is going to be, for argument's sake, 40. All right. So there is a 80 millimeter diameter. Okay. And I'm going to accept that. It generates some geometry that I can see in the back. It's way too big. Right. And so I can just drag that shorter. One of the nice things about family, when you drag that shape handle onto the reference plane, it gives you the ability to lock that in place. That will now follow that reference plane around. Same thing over there. I'll lock it in place. It'll follow that family around. If I select there and I change that to 30, you can see that the extrusion actually follows suit. Right, so this family is now flexible based around this one. At the top, I'm going to go with a, say, 20 millimeter. There, it's also relatively easy. Same command. Go to the top view. Sorry, that's the project. Let me just go back to the family. Go to the top view of the family. Create another extrusion. Again, it's a circle. And it's just going to have a smaller diameter over here. We're going to say that this thing has a diameter, say, of 15. So, accept. So it's quite a thick cable there. Again, have a look at the back. There it is. Drag it shorter. Lock it in place. Now it's following the reference planes. And same thing over there. It's following the reference planes. And what's missing now is the middle. So having a look at the 3D. If we go to 3D, here we can see that we've got this gap between the two. We need to fill that in with some other taper. Right? So we're not modeling every little detail as we would find within a real anchor, because we're more interested in 3D geometry to do clash detection. Although, if it was stated that it should be to that sort of extent, then you could spend a lot of time modeling this family. I don't really see why you should go to that extent, but it's possible. Right? And then in this case, what we'll do is we'll model a taper. So we'll create a blended shape, and we're busy editing the bottom. So when you say edit top, you flip to the top, cancel. All right, so we first have to indicate the bottom. So we'll set the bottom to the anchor base offset reference plane. That tells us where we are working. And so we'll create a circle from the intersect of those. Let's do it at about 30 radius. And then we switch to the top. And when we switch to the top, we also have to set the work plane again. This time it's going to be the top offset. Okay, and then we're going to give it a 0 offset over there so that we don't offset off that top level. And then this time we're going to bring it into alignment with this other circle that we drew there of radius 15. We accept that. We have a look in 3D, and now we can see that that geometry is such. If it's all of the same material, of course, you can join the geometry, but that's not going to hide anything over here. But that's essentially what we want the anchor to look like. It's some other component that we model up. It's face-based component, and then we just have to either parameterize, or we have to just model in the geometry exactly as we require that, and then save the family. So that's part one. We're going to leave the anchor open for part two, and we're going to open a second family, or create a new family, and this time we're going to use a metric generic model adaptive family. They look a little bit different to the normal family editor that you might be used to, but you probably would have seen something like this if you've worked with Revit for a while. And you know, in this case, what we're going to do is we're just going to place 2 points. There's a point 1 and 2. Doesn't really matter where you put them, right? And then we're going to turn them into adaptive components, make them adaptive. You can see how the first one is named 1 and the second one is named 2. The first one we're going to use for the input. That is the sequence of inputs. If you place them into another family or into another project, it's going to go input point number 1, input point number 2, and you have to click them in sequence. To join them up with a curve, you can use this tool up here. It's called the spline through points. If it's just 2 points, then it's just going to be a straight line. Let's save this family as, file save as, a family. And that's the tendon anchor, and I'm just going to put here after that 2-point adaptive. Everything will become clear eventually. For now, what we need is this family over there. It's got a 2-point on that plane, at the base plane where we drew them. And you'll see what happens when we move one of these adaptive points, the points that we place them with. It's got little arrows that you can drag them along in one distance, in one direction, RGB being X, Y, and Z. And then we've also got these little angles that's in the plane that we can actually move them around. So that's the basic idea, is that we've got these 2 points, and they'll be placement points in 3D. And what we do now is we're going to insert, load into project, into the new family that we've created, the anchor. The anchor is face-based, so I'll just put it anywhere over here for now, so that the definition is now within my family. I'm deleting it. And then in the families themselves, I can see there's my generic model tendon anchor. I can place that at will, and now I need to choose my reference plane. Okay, so I'm going to choose set the reference plane, and then I can choose the reference plane on that point. If I want to see if I've selected it, then I can always say show, and it should show me my reference plane exactly where I'm busy placing. Right, so that's perfect. And then it's going to look for point number 1. So there it is, create instance. And I'm going to choose to place SX is the shortcut for placing it on a point. Hover my mouse, it selects the point, and there it is. Right, it's face-based in the center of that plane. That's perfect. And what happens now, you'll see in a moment. Let me switch off the reference plane. What happens now is if I move this point around, then it will reorient this anchor over there. And so I learned this from a video online as well. It's a method that I'll be using in future quite a lot, just to be able to reorient items like that. It's very useful. I'm specifically thinking of wall-mounted televisions and so on, but in this case, of course, it's just that orientation of the anchor. So that's step number 1, and we'll step number 2, and then we'll save this value. But note, if I now click on this element over there, and I go to the type properties, that I can see my anchor and base and length offsets over there. And if I let's just have a look. We're going to edit the type. Yeah. Okay, if it was an instance parameter, then we'd have control over that through the mapping of the parameters. In this case, it's type-based, so that's not possible. So you won't be able to map this. Okay. Interesting. All right. Anyway, that's then either you make those shared parameter instance parameters to be able to manipulate them, or in this case, they won't be manipulated in this adaptive family. Let's save this. And now we are ready for the third part of this demonstration. So to do that, we'll open yet another family. So it's the third family that we are modeling with over here, and this one is also a metric generic adaptive component family. New. Kom nou. My apologies, I'm just trying to get my mouse to respond to me. Come on. There we go. New family. Metric generic model adaptive again. And now we have to create a bunch of points. Now this is dependent on how long the cable is and how many curve points there are and so on. You could go overboard, but remember, for every point that you place, you have to place it within your project as well. So again, it's not critical exactly where you place them, you just need to place them in sequence. So there's 1, 2, 3, 4, 5, 6. Okay. And if you change them into adaptive points again, you can see how it's points number 1, 2, 3, 4, 5, 6. It's interesting when you copy them that the points increment alphanumerically monotonically. So there's 6, 7, 8, 9, 10, 11, 12. That's enough for me for now. It's not going to be a long cable or overly complex cable. Of course, you can curve fit these points. So that's quite interesting that you, after you've created the family, you could also manipulate that within a project using Dynamo. Sometimes these cables are curved in 3 space, which makes them quite interesting, almost like a parametric cubic spline that you shoot items through. And now we can put the line through them. So we just choose all those and fit the spline onto them, and then that's what it looks like. Okay, so we've got the spline. The spline is following the definition of the points. There's not just 2 points, so it doesn't come across as a single line. And that's step number 1. Step number 2 is we're going to place a point to act as a reference point over there, and to act as a reference point over there. Our anchor is 120 long, and so we'll want to parameterize that somehow. There's the point we place. Oops, missed it. If you want to place the point on the line, you have to hover over the line. There's the line. There's the point. We select that point, and we say that the point is going to be defined as per a segment length, and we're going to make that segment length from the beginning 120 millimeters away. And there is the point 120 millimeters away from the end point over there. We do the same thing at this end over here. We place a point, we hover over the line, it's going to select the line, we pick on the line, we select that point, we change that point into being defined as per a segment length from the end, and it's going to be 120 millimeters from the end. All right, so again, if we move part of the line, then the points on the line is going to move along with it. If it becomes longer, it's always going to stay a certain distance away from that line, as you can see over there. So that's quite powerful. Right, and then we need to generate some geometry. And to generate the geometry, we're going to use that point over there. You can see it exposes a reference plane. So we can actually say set the reference plane. We can pick onto that point. That now sets the reference plane. If we show, there you can see how that reference plane is showing around that point. If we had to move the adaptive point to some of the other orientation, you can see how the plane now also changes its orientation, and that's quite powerful. Right. It always stays normal to the curve, so that is a great tool. That's we're going to work on the circle. We're going to draw a reference object. So we draw a reference because using a reference we can actually terminate the geometry. We can type in SX to select the point. We might have to reorbit a little bit to be able to select that point. Come on. Yeah, it's struggling at the moment. SX to snap the point. Doesn't want to do it. Let's try it again. Create a reference element, a circle at that point. It sees this point over there, but it doesn't see this point over here. Okay, let's see if we can change this point definition. It's a reference point at the moment. We don't want the placement point adaptive. Handle plate. I don't want it to be as a shape handle. Right, let's just set the reference plane again, set the work plane. For some other reason it's struggling. Let's do a circle. It wants to pick it up now. There's a reference circle. There we go. Okay, so after we reoriented the line and the reference plane changed, it wouldn't want to select the circle again, so just have to redefine that, and then it picked it up. And let's suppose we make that a, say, a 10mm radius cable or sheath or whatever it is that we're doing. That's now this green line. If it wasn't a reference, then it would be a blue line. So there's one, and we do another one at this end over there. We zoom in, and we're going to place another reference plane over there. So these are set plane, hover over the point to select that point. We're going to create another reference circle. There's our reference circle. We're going to hover over that point, and that's again going to be a 10mm line like that. 10mm radius circle. All right. So the way that Revit generates these solids is interesting. So what we would do is we would select that circle, we would select the spline, and again the circle on the other side, and then we'd simply say, all right, let's generate some 3D form. And there you can see what it does. It uses the definition of the circle, it uses the definition of the spline, and the definition of the circle on the other side to model that geometry. That's how these adaptive component families work. If you didn't have this as a reference, then it would actually fill up the entire spline. And there is our component. So if we move this around, you can see it behaves a bit like a power cable or a normal cable. All right, and these are cables with individual strands, but we're not interested in the individual strands on that sort of level of detail, but we are interested that we do have this sort of cable that we can reorient in any sort of according to these points in 3 space. We can always reorient them within the project, so we can shift them up and down and left and right, and we can manipulate them as we please. And then depending on the number of points, we can actually create more and more complex curves. And if you want to place those curves based on some of the point extraction from a 3-dimensional curve, or a curve fit that you might have measured from site or something like that, then that is quite available to you. Great. All right, so next we want to come and place the anchor. All right, and so to place the anchor, what we're going to do, we're going to just load it in. All right, let's just see what we've got open at the moment. We should still have both of them open. There's the 2D adaptive anchor component. It's going to use point number 1 and point number 2 as the reference point. I'm going to use that with loaded into my new family. Right, and this new family I'm going to call, I'll have to save it shortly anyway, but I want to choose this endpoint, that point, as one of the input points, and now it wants the second input point. I'm going to choose that point over there. So the length is not being controlled by the second point. It is the orientation, right? Because it's face-based anchor, and that face-based anchor is now on this side. There it is. Okay, and its orientation is now controlled by the first 2 points on this line. The one is an adaptive component, or an adaptive point over there, and just some other reference point over there. And that now controls the way in which that element is behaving. Should I change the orientation of this element over there, or change its position, the anchor will go along with that. It stays normal to that point. Same thing on this side of it as well, right? Again, this isn't me that came up with this methodology. I've also learned this online. Just thought I'd show it to you quickly, and then if it is of interest to you, then you can adopt that within your own workflow. So let's save this. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 points, right? You can do one with more, you can do one with less. And let's save this as file, save as family, and that family we can save as a tendon anchor, just a tendon, I'm just going to go tendon 12 point adaptive. Okay, there's my tender 12 point adaptive, and I load it into project and close. And as you load it into a project and close, now it's going to want to place one, right? And it's going to want to place 12 points. That's because that's how it works, right? So let's just look at A through until 1. I'm going to draw it on the side of the building here, so you can see what's happening. There's 1, 2, 3, 4, 5. Let's carry on. 6, 7, 8, 9, 10, 11, and 12. After you've placed the 12th item, that is the placement of one of those. Right. Let's have a look in 3D. What does it look like? On the side of the building. Let's have a quick look over here. It's discipline is set to structural. If we set that to coordination, just see what's hidden. Section blocks is off as graphics overrides. Where is this thing now? Let's do this with the graphics overrides. Generic models are on. Okay, it's just that we modeled it in the new phase. It was just a phase setting, and there we can see what this item looks like. It will now schedule, because it's shared, it will schedule that component. We'll just have to filter it out somehow, but you can see how we've also got these points. So when you hover over this element, there's an adaptive point that you can choose, and that adaptive point you can move around. So if you want to reorient what this cable looks like in 3 space, so you can see how we can curve that cable just by clicking on one of those points. We can move one of those points up and down. Right, so how you arrange this within your structural elements, that's going to be up to you, but it's then a 12 point that is available for you to orient as you wish. So I hope this short video helped you to understand how we link the families together. There's many other examples of this online. It's not too difficult to do. You might even be able to find some elements from companies that already do this professionally. I did see some add-ins that's available. You'd have to investigate them for yourself and see if it's worth the money to purchase one of those add-ins. But if you just want to model the 3D geometry and you know what you want, and you want to do it on your own, model your own families, that's the way to go about that. Well, I hope you've enjoyed this short video, and until next time, enjoy Revit.